Yes, hello. So today we will discuss about this one that the body is said to be rigid. Some points of mechanics. So the body is said to be rigid if the relative position of any two particles do not change under the action of any forces. Means consider a body. If you consider one body, so it will not change its position until an actional force acts on it. So it will not change its position. So that is the meaning of this sentence. So next point is Newton's law of gravitation. So there are Newton's laws of motions. So first law, second law, and third law we have studied. So first law is nothing but an external force. First law is nothing but the body will continue in motion or at rest until and unless an external force acts on it. So if the body, for example, this body is, we are calling it as A, it will be considered stationary or at rest or in motion. Motion is limited with a uniform motion. So that motion, until and unless if you disturb that body with the help of any force, the body will be stationary itself. So stationary is the constant one. So next, second law of motion is nothing but the momentum is directly proportional to force of the body. Sorry, the rate of change of momentum is directly proportional to force. That is, F is equal to, you can call it as F is equal to M into A. So this is the formula. So M into A, that is a one. Next, F is equal to M into A. Next one is the Newton's law of Newton's third law. Third law is nothing but it is for every action there is a equal and opposite reaction. So another one law is the Newton's law of gravitation. So that we can see everybody attracts to the other body. The force of attraction between any two bodies is directly proportional to their mass and inversely proportional to the square of the distance between them. So Newton's gravitation, everybody attracts the other body. So everybody, for example, we human being will be attracted by the earth, and everybody attracts the another body. The force of attraction between the two particles is directly proportional to their mass. So if you consider proportionality, directly proportional to their mass and divided by direction proportional to the mass and inversely proportional to the square of the distance between them. The force between it is inversely distance between them. So for example, D if you taken as a distance, so this is a distance as well. So if you taken D as a distance, so square of the distance between them. So this is a formula for gravitation, Newton's law of gravitation. So next, the qualitative description of physical variable is known as dimension. So physical variable means if a particle is having size of for example B into D, so B into D, or we can take it as a 12 meter into 13 meter, or you can call it as 13 meter. So this will be again goes into changes under the change, and it will convert into 10 by 11 or 14 by 16, like that. The dimensions will change. So that is, we are calling it as qualitative that is a physical variation. It is nothing but the dimension, while the quantitative description is known as unit. So quantitative means how much amount it has changed. For example, if it is having one metal is having 10 kgs, so after that it will reduce to 8 kgs. So that kg we are calling it as unit here. So next is law of parallelogram force. So it is a very important law. So in this force, in this law of parallelogram, just we will study some. So this is a one parallelogram. So this is a parallelogram, you can call it as. So So this, in this parallelogram, whatever the resultant drawn, the resultant is the product of these two forces. Means we have to determine resultant here. So resultant, there is one formula, that is this force square plus f1 square plus f2 square plus 2f1 into f2 cos theta. Theta is nothing but this is a with respect to x-axis. So this one we are calling it as law of parallelogram. Let's see what is the definition of law of parallelogram force. The parallelogram law of forces states that if two forces acting simultaneously on a body at a point are represented by the two adjacent sides of a parallelogram. See here. So in this, the body, it is considered as a point. So in this is the one force F1 and this one is second force F2. It is considered as F1 and F2, two forces, and these we are calling it as adjacent side of the parallelogram. Next, their resultant is represented in magnitude and direction by the diagonal of the parallelogram, which passes through the point of interaction of the two sides of representing the forces. So here the resultant is represented by the same point of interaction. Point of interaction is equal the point where the forces will join. So this is the point of interaction. So from these forces we are drawing this resultant, and it is a diagonal of this parallelogram. So it is a diagonal of this parallelogram. This is, we are calling it as law of parallelogram of forces, and angle will be theta with respect to x-axis, or with respect to one force we can call it as. This much is some points of introduction of mechanics.